All right, guys. So we're in the last stretch of Unit 7. We're in the last stretch of Unit 7. So we're just going to go through the review. This is the review warm-up. So we're going to solve this system in 3 ways. We're going to graph the system. When we're graphing, the requirements are, we're going to write our requirements. The requirements are to get y by itself for both equations. Okay? Now, for equation number 1, I have 2x minus y equals 4. For equation number 2, I have 3x minus y equals 2, right? I want to get y by itself, so I'm going to put a little 1 in front of these y's. And the first step I take when I'm doing this is subtract my x term, right? This goes away, negative 1y comes down, equals 4, minus 2x. Next step, divide negative 1 from each term. So I get y equals negative 4 plus 2x. Then I'm going to go to y equals. I'll go to y equals, press y equals, put my equation in, clear, and we're going to get a table of values. So I have negative 4 plus 2x, press second graph to create my table, and I get negative 1, negative 6, 0, negative 4, 1, and negative 2. So I have x and y, negative 1, negative 6, 0, negative 4, positive 1, and negative 2. Okay, so I'm going to graph those three sets of points. So left 1 down 6, left 1 down 6, all right, there's my first point, right? Stay at 0, go down 4, right 1 down 2, and if I keep going, it looks like a pattern of up 2, right 1. I'm going to create my straight line, right? So that's my first equation. Don't make this ugly line that I just made. It's a shame. We don't want to be shamed. But apparently I am. So my next equation, I'm going to look at it. I have 3x minus 1y equals 2. First step, move the x term to get y by itself. This goes away. Negative 1y's comes down, equals 2, minus 3x's. Divide each term by negative 1. And I get y equals negative 2 plus 3x's. Now, I create a table of values here. So I put this equation in. Go to y equals, put in negative 2 plus 3x's. Press second graph. And I have negative 1, negative 5, 0, negative 2, 1, 1, right? So I go plot these points. I go left 1, down 5, left 1, down 5, 1, 2, 3, 4, 5, right? I go 0 and I go down 2. I go to, I'm going to do this in red so we can see this a little bit clearer here. Down 2, right? I go 1, 1, so right 1, up 1, right? Now, I'm going to redo my initial line a little bit because it looks messy. I'm going to redo my initial line. I have like left 1, down 6, so 1, 2, 3, 4, 5, 6. All right. Then I go 0, down 4, and I keep going up, 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 right? There we go. There's There's my first equation. So I just redid the equation, that's all. Now my second one looks like I'm going up 3, right 1, up 3, right 1, up 3, right 1. Okay. 2, 3. All right, so create this line. And if I look, I don't have enough space, but it crosses somewhere below. It crosses somewhere below. So perhaps we can identify the solution. That's not a good equation, okay? But it's this intersection right here. It's the intersection here. So what I'm going to do is just put my two equations into y equals and see where my y values are the same. See which x value produces y values that are the same. So I have -2 plus 3x already in there. So I'm going to put -4 plus 2x. And I'm going to go second graph. And it looks like it's negative. So I'm going to keep going up. And if I look, it's at, my y values are the same at -2. When x is -2, both of my y values are 8. So my solution is x comma y maps onto -2, -8, right? Now, what about, how can I use substitution? Well, you need at least one equation with a variable by itself, right? So I'm going to pick number 1, and it's the same equation, 2x minus y equals 4. So I'm going to subtract 2 x's on both sides. I'm getting y by itself. I'm meeting the requirements. I'm getting at least one equation with y by itself, right? Divide each term by -1, and y equals -4 plus 2 x's, okay? Now I can go back and do the work I need to do. So I'm going to plug that into right here. So 3x minus what y equals. So what does y equal? It equals -4 plus 2x. And remember before what I said about what happens when a parentheses has a negative in front. Well, what happens is that negative changes the signs of each term inside. So negative changes that -4x to a positive 4x. And then that negative changes in positive 2. Sorry, that's not 4x. That's a positive 4. Change that positive 2x into a negative 2x. And this equals 2. Okay? Now I combine like terms. 3x's minus 2x's is 1x. So just x plus 4 equals 2. Subtract both sides by 4, right? And x equals -2. Now, what about y? Well, I know that y equals -4 plus 2x's, right? So I'm just going to drag that on up here and go with it, right? So y equals -4 plus 2 times -2. This equals -4 minus 4. This equals -8. So my answer here, x comma y, maps onto -2, -8. Now, why are these two answers the same? Why is this the same graphically and then the same by substitution? Because it's the same equations. Look at the system. This is the same system. We're using different methods to find an intersection. The first was graphically, the second was by substitution, the last is going to be by elimination. I'm not going to go through, I'm not going to write down what we need to happen for elimination. I'm going to tell you. So for elimination, we need two terms with coefficients that are the same. So here, coefficient is 1, and it's 1 below. We also need those two terms to be opposites. So how can we get 1y, -1y, and -1y to be opposites? We need to multiply one of those equations by -1. So we're going to choose the bottom. When we multiply by -1, all we're doing is changing the signs of each term. So this becomes -1 times 3x is -3x. -1 times -1 is +1y. -1 times 2 is -2. Okay. Negative 3x plus 2x's is negative 1x. This goes away. Equals 2. Divide both sides by negative 1. And x equals negative 2. Now I need to find y, so I pick an equation. I typically pick the first one. So 2x's minus 1y equals 4. So I know what x is. It's 2 times negative 2 minus 1y equals 4. That's negative 4 minus 1y equals 4. Subtract 4 on both sides. Make sure I'm doing this correctly. And yeah, I am. So I'm going to add 4 on both sides, and I get negative 1y equals 8. Divide both sides by negative 1, and y equals negative 8. So my answer here, when I'm using elimination, is negative 2, 8. So x, comma, y maps onto negative 2 and 8. Negative 8, sorry. Okay, so we're going to go ahead and start the review. So the first thing we're going to do is to solve by graphing. So you can use any method that you wish to, but we're going to solve by graphing. So we're going to create 2 tables. But first, let's make sure both equations are by themselves. So equation number 1, y is already by itself. Y equals x plus 3. So I'm just going to create a table of values there, right? So I go to y equals and put my equation in. Go to y equals, clear out both equations or any equations that are in there. X plus 3. Second table, second graph, and I have negative 3, 0, negative 2, 1, so on and so forth. Negative 3, comma 0, negative 2, 1. So left 3, stay at 0. Left 2, up 1. Left 1, up 2, and so on and so forth. Okay? So here's my first equation. This is y equals x plus 3. This is equation number 1, right? What about equation number 2? Well, is y by itself? No, it is not. So I'm going to subtract 2 x's on both sides, right? I get y equals negative 2x, period. Now I'm going to go to my graphing calculator. I'm going to put this in my graphing calculator and get some x and y values. So go to y equals, clear the equation out. That's there. I have negative 2x, second table, and I have negative 2, 4, negative 1, 2. So negative 2, 4, negative 1, 2, and it keeps on going. 0, 0, right? So I'm going to go ahead and graph those points. So negative 2, up 4, right? Negative 1, up 2. There's my intersection. 0, 0, and I can just keep going. And I create my line. And here's my intersection. My x value is left 1, so negative 1. Y value is positive 2. So you're not done. Make sure you write this out. Write your solution as a point. Negative 1, comma 2. Close it. Next problem. Y equals 2x minus 5. X plus y equals 4. Now, I'm going to use substitution because the y is by itself. I'm going to use substitution because y is by itself. I'm going to replace the y. So that means my second equation, I have x plus, what does y equal? 2x minus 5. And remember, we put expressions into parentheses. So that gives me x, parentheses just fall away because there's no negative, there's a number in front to distribute, right? X plus 2x is 3x's, minus 5 equals 4. Add 5 to both sides. I get 3x equals 9. Divide both sides by 3, x equals 3. Now, what about what y is? Well, y equals 2x minus 5. I'm going to plug x in, and I get 6 minus 5 equals 1. So my solution is, well, my x value is 3, my y value, comma, is 1. All right? Now, next, what method do you want to use? I would say, ask yourself, if the x and y's are on the same side, could you use elimination? Could you use substitution? Which one's easier? I think for this one, since I have two terms where the coefficients are the same and they're opposite and it's in the standard form, I better use elimination and solve for x first. And then I'm going to solve for y. Number 4, I could use elimination, but I think it's best to just solve for y for one of these equations and use substitution. So I'm going to choose substitution for number 4. You can make your choice how you want to do that. So I have what I need. It's already set up for me. So 7x plus 1x is 8x equals 32. Divide both sides by 8, and x equals 4. Easy stuff. Now I need to find what y is. So y, 7x plus 8y, I'm going to use the first equation, equals 24. You can use the second one if you want. And x equals 4, so 7 times 4 plus 8y equals 24. That's 28 plus 8y's equals 24. Subtract 28 on both sides, and I get 8y's equals negative 4. Divide both sides by 8, and y equals negative 4 over 8. If I simplify, that's negative 1/2. Now, how do I write my solution? Your x value always comes first, so 4, comma, negative 1/2. That's my x and y. Now, I've been telling you to map these numbers, but at this point in time, you're so savvy and so good right now that it's not going to matter that because you already know what your x and y is. That's the proof of point, that you know what you're talking about. Now, number 4, we're going to solve for y. We're going to solve for y for the first equation. So I have y, sorry, that's not what it says. It has negative 8x plus y equals negative 5. Get y by itself, so you move the x term, right? And you get y equals negative 5 plus 8x's, right? We got y by itself, and now let's solve for x. So we replace the y with what it equals. I know that y equals this. It equals negative 5 plus 8x's. I have to distribute. So I have 12x's. If I'm distributing negative 3 to the first term inside, I get positive 15. If I distribute negative 3 to the second term inside, I get negative 24x's equals negative 9. Right? So combining terms, 12x's minus 24x's is negative 8x's plus 15. So I mark out what I've used, right? Equals negative 9, subtract 15 on both sides. I get negative 8x. Well, this equals negative 24. So at the end, I'm looking for x and I'm looking for y, right? So negative 8x, negative 8 divided by negative 8 on both sides, I get x equals 3. So x is 3. Now I need to find y. Well, I know that y equals negative 5 plus 8x's. This equals negative 5 plus 8 times 3, or negative 5 plus 24, which is 19. That is a big number. You shouldn't get any fractions. Well, there's going to be one, but not a lot of fractions for coordinates answers on your test. All right. So now Uh, for number 5, you're only asked to write the system of equations. So if you look at the lines, it tells you what to write. So the first step when you're doing this is to underline, kind of outline what you're looking at. So it says you want to buy some shirts. So I want to buy some shirts. And I want to buy some pants. So we don't want to play games. We know we want to buy some shirts. We want to buy some pants. So I'm talking about shirts and pants. Let's give them shirts and pants. All right, so we're going to underline our first statement. So a pair of pants costs $14.50 and a shirt costs $12. All right, so for the cost, all right, we're talking about cost here. My first equation is talking about cost. So pants, $14.50. So every pair of pants, so $14.50 times P plus $12 times the shirt. Every shirt I buy is $12. So if I bought 2 shirts, 12 times 2, right? This is the cost. Now, how much did I spend? Well, I spent $113. So this equals, that's my first equation. So $14.50 P plus 12S equals $113. Now, my second statement says it's talking about the items I bought. It says I bought 9 items. So what did I buy 9 of? I bought shirts and I bought pants. So my second equation is shirts plus pants equals 9. Don't make it harder than that. Figure out the cost and figure out what they want you to add the total up to be. All right. Next, we're going to have some systems here. It wants you to determine the number of solutions for the linear system. So if it's one solution, you're going to have one set of coordinates. You're going to have an x, you're going to have a y. If it's none, then you might end up with 2 different numbers. So 2 does not equal to 3. If it's infinite, you might end up with a situation where you end up with a number equals a number. So how do I go about solving these? So first, let's see if the slopes and the y-intercepts are the same. Let's check slopes and y-intercepts for each equation. So we're going to get y by itself. That's one method I was talking about. But what we're going to do, it says hence solve each equation for y and compare m and b. So we want to know what m is for this first equation. So we're going to create a little table here. What's m? What's b? Right? M and b for each equation. Now, let's check what we have down here. If the slopes are different, if the numbers for the slopes are different, we have one solution. If the slopes are the same, but y-intercepts are different, we have parallel lines. We have no solutions, right? So at the bottom, we're going to indicate what type of equations we have here. So first, this first equation, so equation number 1, I'm going to solve for y. All right, so that means I move negative 2/3 over, right? And 2/3 x over, and my 4y comes down, equals negative 8 minus 2 over 3 x. Want to get rid of x, the 4, so I divide each term by 4, right? This goes away. I get y equals negative 2 and minus 2 over 12x. Now I want to simplify negative 2 over 12, so I'm going to go to my graphing calculator, press second mode, press math, enter, press alpha y equals, we're going to just put it in fraction form, negative 2 over 12. This simplifies to negative 1 over 6. So my slope for the first equation is negative 1 over 6. My y-intercept is negative 2. So we want to make sure that slopes are not the same in order to get one solution. So solving for x for my second equation, solving for y for my second equation, we're comparing the slopes. It's another method for determining if we have a solution or not. So add two x's on both sides, right? And negative 12y comes down equals 24 plus 2x's. Divide both sides by negative 12. And I get y equals negative 2. So far, so good. Minus 2 over 12x. And remember what I told you. We have to simplify this number. And we did it earlier. And it simplifies to negative 1 over 6. So for my second equation, my slope is negative 1 over 6. My y-intercept is negative 2. So looking at both equations, we're going to go figure out how many solutions we have. We have the same m and the same b. So these are infinite solutions. For number 6, you're going to write the answer. There are infinite solutions because slopes and y-intercepts are the same. In the middle is a little key that tells us this, right? So I'm going to make this smaller here. Yeah. This is going to go away. It's just making stuff smaller so I can work on the left, on the right, Okay, so on the right, still we're in the same situation. We're looking for the slope of each line and the y-intercept of each line, right? So I have x plus 3y's equals 3. And then I have 2x's plus 6y's equals negative 5. So I always move my x term first if it's not where it's supposed to be, which is when I'm getting y by itself. Equals 3 minus x, divide both sides by 3, and I get y equals 1 minus 1/3 x. So here my slope is negative 1/3, y-intercept is 1. Secondly, over here, move my x term, right? I get positive 6y's equals negative 5 minus 2x. Divide both sides by 6, or each term by 6. Y equals negative 5 over 6. So my y-intercept is negative 5 over 6. My slope, when it's simplified, becomes negative 5 over 6 minus 1/3 x. So I have negative 5 over 6. My slope is negative 1/3. So slopes are the same, but y-intercepts are different. So here, there are no solutions. There are no solutions, right? Now, next, we're going to sketch the solution to the system of inequalities. So I'm headed down. I know m equals negative 2 over 1. b equals 4. For my second one, m equals negative 1 over 2. b equals negative 2. All right? And for second one, I'm shading up, right? Now, let's talk about what we're going to do. So equation number 1, I'm using that y-intercept. It's at 4. And I'm going to go down to right 1, down to right 1, down to right 1, down to right 1. And I keep going. Now, it's solid, right? And I want to shade, I'm shading below this line. And remember what I told you before, we're looking for the section of overlap, So I'm going to use red for my second equation. So this is number 1, this is number 1. And this yellow area indicates all of the space where The equation is true. Number 2, I start at -2. I go down 1, right 2, down 1, right 2, right? And I can go back the other way. Now this is a dashed line. It's not solid. So we're going to do this one in blue. I'm going to do this one in blue. And I'm just going to look at where does it overlap. And the great thing about highlighters for me is it shades what I need to. So I shade above the line. So I shade above the line. And I'm going to go ahead and thoroughly shade. I'm going to go ahead and thoroughly shade. So we can see the overlap where it's green. All right? And as a matter of fact, I'm going to go back through with the yellow so it's even clear, right? Everywhere that's green, this is the solution to that system. Everywhere that's green, this is the solution to both equations. This is green area. The overlap is the solution to both equations. Now, the solution to a single equation, there's below and above. That's in the blue and the yellow. Okay? So, things we want to point out on our test, the solution to the system is the shading overlap. Okay? Now, why is it important to me that you be able to see this that way? So let's look. It says Kimberly began graphing the system of inequalities shown. To complete the graph, Kimberly must shade the region which represents the solution set to the system of inequalities. What region of the graph needs to be shaded? So first, look at the first equation. They already have some lines there. Maybe you can't tell which one is which. So I want to know which line is number 1, which one is number 2. So first, my slope for equation number 1, this is number 1, is 1. So 1 over 1, y-intercept equals 2. So I'm going to go to 2, and I'm going to go up 1, right 1, and keep going. And it looks like this is my equation. This is my equation. Now, that means this one is equation number 2. So let's talk about shading. How do we want to shade? We're going to shade one at a time. This time, I'm going to use the blue pen to denote my shading. So equation number 1, I'm shading below the line. Actually, I'm going to highlight. So I'm going to highlight yellow below this line. Don't worry about the numbers yet. Those represent sections that the graph are partitioned off at. They represent sections where the graph is partitioned off. Now, that's equation number 1, right? Equation number 2, we're going to do in blue. That's obviously that vertical line. So for greater than, if a number is greater than that x, if x value is greater, am I going to move to the left of a line or am I going to move to the right? All greater than is to the right. Now, it says, remember before I told you, your job here is to figure out the solution to the system. It's always the place where it overlaps. Solution to the system, right? So what are they asking for? What region of the graph should be shaded? What is the solution? What is the shaded solution to this system? It's region number 3. Okay? Now, for the next two parts, we're going to select the points that are part of a solution set. Then we're going to create a system of 2 inequalities that could be represented by the graph. So we're going to move to page 30. So how do I do this next problem? You're going to graph each point. And what we want to check is, does it fall into the shaded area? Okay? So I'm going to go left 1, down 1. So left 4, down 1. Does it fall into the shaded area? Yes. Now recall, if it falls on the dashed line, it's not a part of the solution. If it falls on a solid line, it is. Okay, so I go right 2, up 1. So right 2, up 1. That's not an answer. I go left 3, up 3. So left 3, up 3. This is on the dash line, so that's not an answer. Then I go left 2, down 3. So left 2, down 3. It's on the solid line, so this works. It's still a part of the shaded region. And I go right 4, down 5. So right 4, down 5. Not in the shaded region. I stay at 0 and go up 1. It's on a solid line, but it's not in the shaded part. So this is not 1. Okay? So you should have had 2 distinct answers here. Next, it says choose 2 equations from the table to represent the equations over here. Choose 2 equations from the table to represent the equations over here. So I don't like the way this is written, so I'm just going to rewrite it. I'm going to flip it over. Y is less than or equal to 2x plus 1. Y is greater than or equal to 2x plus 1. Y is, I'm flipping the symbol over, less than 2x plus 1. Y is greater than 2x plus 1. So what I'm looking for an equation with a slope of 2 over 1 and a y-intercept of 1. For my second one, I'm looking for an equation with a slope of -2. Remember, we can create -2 over 1, and a y-intercept of -3. So I'm just going to check which one has a y-intercept of -3. This dash line does. So we're shaded below. It's shaded below. And so y is less than. It's less than whatever my y-intercept is. So mx plus b. So m has to be, the slopes are all the same, -2 over 1. X. Simplify, that's just -2x minus 3. So y is less than, so here's my first one, and I'm going to just come over here and rewrite it. All you have to do is make the connections, all right? All we're doing is checking the line of each one. So this one, I can mark it out. I've already taken care of that line. So obviously, the next one has a y-intercept of, let's say y, we have 2x plus 1. I just need to figure out what the symbol is. So it is equal to, that eliminates this one and this one. I just need to figure out how the shading is. If I'm shading up, then y is greater than. It's greater than, so it's got to be this one. So I have y is greater than or equal to 2x plus 1. Okay? Now it says find the slope of a line that passes through the points. You're going to have to remember the slope formula on your test. I already have it here for you, so I'm just going to write this out. 4, 2, and 2, -4. Now I'm going to label my points. x1, y1, that's my first set. x2, y2 is my second set. So y2 minus y1, this equals -4 minus 2 over 2 minus 4. This equals -6 on top, -2 on the bottom, or 3. There's my answer. Then it says create a table of values for the linear equation 1/3 x plus 1. You go to y equals, and remember we don't use fractions here. We don't get fractions in our table. Press clear, alpha, y equals, and get the fraction part, right? It's not working for me. So I'm going to type in 1/3 times x. That's my 1/3 x. Plus 1. Go to the table, second table, and I see -3, 0, 0, 1, 3, and 2. -3, 0, 0, 1, 3, and 2. and you're done. That's your answer. All right. Number 14, it says circle all of the relations that are functions. Remember, functions have no repeating x values, and they do not touch vertical lines in two places. So here's a vertical line. Here's a vertical line. I can see I have a vertical line that's being touched in two places by that circle. So this is not a function. Now, if you take a vertical line, you run it through this function here, this graph, it is a function. This is a function. This is a function. All right, now look at inputs and outputs for the next chart. Are there repeating x values? I have 2 paired to 3, 5 paired to 4, 6 paired to -1, and 8 paired to -1. Okay, so this is a function. I'm going to circle it. Right? Now, look at the next one. If I have a vertical line, does it go through more than 2 points? Yes, it does. It does here, and it does right here. So this is not a function. I put a big X through it. Look at the last one. Are there any repeating x values? No, there are not. So this is a function. Okay? And that's essentially everything. Do the review homework. Good luck with that. And make sure you realize that solutions are also intersections. Have a great day, guys. Thank you for watching the video.